So I will just introduce myself. I am Wang, and I'm the director of the Aerosol Science Research Center, and also the professor in the Department of Chemistry at National Science University. So I will begin my talk. Okay, so I would like to share with you some of the quantum nature of breathing and sensation, or our five senses, to address the planetary health and our health. And we have learned from ancient Greek time that all matter is actually made by atoms and molecules. And then later on, Dalton developed this atomic theory to address this in a more accurate way. And as you can see, this is how we depict the molecular structure of oxygen, and this is the structure of water, and this is the structure of hemoglobin, which is the active molecules in our blood. However, with the advance of the quantum mechanics, it opens up a new avenue for us to see the world in a different ways. Many of you might have known Bohr. He is a Danish quantum physicist who has developed this Bohr's model of atom, that the atom is comprised of a nucleus composed of protons and neutrons, and also surrounding by electrons. Although this model has been modified because it is not entirely correct after the development of Heisenberg's uncertainty principle, we cannot really depict the electron orbiting around specific trajectory. Nevertheless, Bohr's model paves the important foundation for the development of quantum mechanics. However, there is an important quote from Bohr. He mentioned that everything we call real is made of things that cannot be regarded as real. And as also brought up earlier, Max Planck, he is a German physicist and also regarded as the father of quantum physics. As mentioned by Professor Wang earlier in the black body radiation. So Planck proposed that the energy should be quantized to really explain the black body radiation. And this famous formula, E equals h nu, this h is actually named after Planck. That is the Planck constant. But Planck also mentioned once, this is a very famous quote from Planck, as a man who has devoted his whole life to the most clear-headed science, to the study of matter, I can tell you as a result of my research about the atom this much: there is no matter as such. Well, you might wonder, those outstanding quantum physicists, they told us that there is no matter as such. Then what is the matter that we see, we touch? Then what is the nature of the universe? Another outstanding physicist, Nikola Tesla, he mentioned that if you want to learn or find out the secret of the universe, think in terms of energy, frequency, and vibration. And Planck also mentioned in a different wording, he mentioned that in my own research, I have never come across matter. To me, the term matter implies a bundle of energy which is given form by an intelligent spirit. So how can we describe this kind of energy, vibration, or frequency? For this, we need to understand, or you might or have already heard about the particle-wave duality. In the classical mechanics, we treat matter as particles, and we treat light as wave. But with the advancement of quantum mechanics, we came to realize that light also exhibits the particle-like properties due to the discovery of photoelectric effect and other effects like Kempton effect. And also, In contrary, matter, to our surprise, it also exhibits the wave-like structure, thus wave-like property, owing to the discovery or the development of de Broglie. He proposed that matter also have wave-like property. And another very famous experiment is Young's double-slit experiment. He showed that electron actually exhibit a wave-like property. So how can we describe this kind of wave? Schrödinger is another important figure in the quantum mechanics development. So he developed the wave mechanics so that we can describe matter and its correlation with energy in terms of Schrödinger's equation. So all the students who take quantum mechanics or quantum chemistry has to learn to solve quantum Schrödinger's equation, but we are not going to solve it today. But I want to just share with you that from this equation, you can see that we have this Hamiltonian operator that is to set up the potential operator and kinetic operator. But by solving that, we will be able to solve the wave function of matter, and also its corresponding energy state. That's the solution that we always try to find. And what is the meaning of wave function then? It is to describe how the particle as a wave populate in the space, and with the square of the wave function, we are able to find out the probability of finding electron at certain space at certain time. That's why we call the probability density, as also brought up earlier by Marcus. Yeah, and sometimes we just call it electron cloud because it doesn't really orbit in specific trajectory, but we more like to describe it as the population probability density, like a cloud. Okay, and Schrödinger's cat is probably very famous because he has a cat with the thought experiments. So the wave function can be described as the superposition of a cat with being alive or dead. Okay, so this is an example to show you how the hydrogen electron wave function look like. So this is the formula of the hydrogen wave function, and with different quantum number, we will be able to solve when the quantum number at the specific states, then this is how its orbital or its electron cloud look like. So people always thought that quantum mechanics may be only applied at the microscopic level. However, in our macroscopic world, what do we have something to do with quantum mechanics? The breathing, and what does it have to do with quantum mechanics? Let's find out, but let's take a deep breath again for now. Yeah, so when we breathe, you can feel that the air comes into our respiratory tract and then into our lung. And then the air would get deep into our alveolus, and then the oxygen or the air will permeate through the alveolar layer to enter into our bloodstream. And at this point, hemoglobin, which is the active molecule, would take over and load up oxygen, carry it into all our organs and tissue cells to sustain our life. And this is the structure of hemoglobin. You can see that it is comprised of 4 subunits, and each subunit has this heme functional group. Okay. And then at this very moment when we are breathing, actually the molecule of hemoglobin in our body is actually working very hard to breathing as well. So by doing that, it actually carry out through this conformational change of the heme group. So you can see that when it is deoxygenated, it is actually out of plane. And when it catches oxygen, it becomes in-plane. So by doing out-of-plane, in-plane, our molecule is doing the breathing at a very quantum level. And we cannot see it, of course, but the modern technique, the spectroscopic, allow us to see this. So this is the resonance Raman spectroscopy of hemoglobin measured in our lab. So you can see two curves. One is the purple curve, one is the orange curve. And you can see this shift, what we call spectral shift. And that is actually when hemoglobin carries oxygen and release oxygen, they are in a different state at different frequency. And we are allowed to observe it from the vibrational spectroscopy. So we need to be thankful for the hemoglobin, which works very hard to sustain our life. And that is the quantum nature of breathing at the microscopic and quantum level. How about our five senses? So in our daily life, we can see, we can smell, we can hear, like the gong performance that we heard earlier this morning. And we can taste, and we can touch. So what is the quantum nature behind all five senses then? Let's take a look at the vision first. So the reason we can see is actually the light strike into our eyes. And within our body, there is a detector of those photons we call retina. Okay, so this is a simple layout to show you. The light comes in and it hits our vision system, and then after the interpretation of our brain, then we recognize the color of the object. However, have you ever thought about that? The world seen by us and seen by other different animal species are actually different. The vision, the visible range of human eye is only a tiny fragment of the whole spectrum of electromagnetic radiation. Our visible range is only from 400 to 700 nanometer. Behind those, we can no longer see it because of the limit of our eyes. But other different animals, they can sense different regions. So we don't see it doesn't really mean it's not there. And many instruments can help us to observe it. And actually at the atomic level, what's happening is the rhodopsin, which is the light-sensitive receptor protein. And it happens when the light comes in, then it can initiate the isomerization of this protein between different conformation states, cis and trans state. And earlier, a study published in Nature, which is a very impactful journal, the scientists found out the ultra-fast structural change of the first molecular event in vision, which takes place at picosecond level, which is the 10 to the minus 12 second. So you can imagine it's really, really fast. It's beyond our sensation, but that's what's happening at the quantum level. How about hearing? The auditory system is, again, the detector for us to perceive the vibration, the external vibration. And the auditory field also varies with species. So human ear can only hear the sound between 20 to 20,000 hertz. But other different animals, they can hear different sound, different range of sound. And this is a layout of our auditory system. So you can actually see our auditory system, our ears, is really very delicate detectors to receive the external vibration which propagated through our ears, the outer ear, middle ear, the inner ear. Eventually, this kind of vibration reach our brain, and then our brain will interpret to process the signal to sound that we hear. However, sound itself is also quantized. So the sound quantum physics, which is also known as quantum acoustic, which is the study of sound at the quantum level, which treat the sound wave as the quantized particle called phonons. Here are just two examples of the journal, one published in the PRL, Physical Review Letter, and the other proposed the quantum vocal theory of sound. And you might just wonder, sound has different frequency, but can we actually see it? With the advancement of cymatic, people can use certain kind of medium like sand or water, and when the sound is produced at a certain frequency, it actually generates some patterns which allow us to see the structure of sound. Then let's take a look of smell. We can smell because of the olfactory system in our bodies. And again, when we smell something, like when you smell some food or smell some odors, that's actually some chemicals that's entering our olfactory system, and the receptor of the olfactory cells can interact with the chemical and then proceed into some signal to your brain. Well, now you smell something. But the latest research show us that the sense of smell may actually be closely related with quantum tunneling effect. There are now two commonly perceived models. One is the lock and key model. So that basically we have receptor, and the smell, the molecule of some smell exhibits certain shape, and then it's like the key and lock. However, this model has some drawback because it couldn't really explain why certain isomers can have different smells. However, with the development of this new theory, the vibrational assisted electron transfer model, it can actually explain this. So this is inherently a quantum phenomena. So the electron transfer between the electron donor and electron acceptor, and then through this quantum tunneling, that is in charge of the smell that we, our olfactory system has. How about taste? It's similar. Again, it's also in quantum, at the quantum level works. And actually recently some food industry like Nestle's, they are already applying quantum physics to simulate, to tune the recipe so that their food or their product or the coffee can taste better. Or the cookies, they can taste better because it can try to simulate how the food can have better interaction with the receptor of our taste system. But how about beyond 5 senses? Usually we have 5 senses, but some animal species has been proved to have the 6 senses, beyond 5 senses, like some birds. They have the magnetoreceptors or magnetosensitive proteins, and they can sense the Earth's magnetic field, which allow them to migrate over long ranges. And some recent studies also show that some human being might also has this kind of magnetosensitive molecules in our body, but this is still the ongoing research. But I just want to show you that all our 5 senses, or the 6 senses from some animal species, all work at the quantum level. So here are some important messages that I try to share with you. By realizing the connectedness, it is also emphasized by Professor Wang and Marcus. This connectedness functions at a very quantum level, and it connects us all. It connects everything. So our five senses is no more than the detector system equipped in our physical body, which allow us to perceive the light, the sound as the vibration, and the smell or the vibration or the touching or the mechanical force to help us sense or to perceive what's going on in our immediate surrounding. But from the very beginning I mentioned, matter is actually energy by nature. So another point is that what we sense might not always be true, because it might be sometimes the malfunction of our, for example, auditory system or visionary system. But so the information we obtain relies on the hardware that is our detector system, and sometimes also the software that is the neurological signaling pathway, and it needs the perfect function or perfect collaboration between the two aspects to help us correctly sense what's going on in our surrounding. However, just because something cannot be seen or heard, it doesn't actually mean it doesn't exist. It's just because it can be beyond the limit of our sensation. And another key point is that the fundamental nature of all things is quantized by nature. They can be described by wave function, and they have their corresponding energy states. And this also echoes with Marcus' information, quantum information. What kind of information, and how can we find out the information? So molecule can have different levels of energy state. We can have electronic energy level, we can have vibrational energy level, we can have rotational or even rotational vibrational level. And this can be actually observed from the modern spectroscopic techniques. Yeah, and then once we realize that everything is energy, and we are actually part of the whole system, then you might have different thought when we encounter the air pollution. Air pollution also impairs planetary health. And it doesn't just only impair planetary health, it also impairs our health. By inhaling the air pollutant like PM2.5 or some anthropogenic aerosol, it has been shown to impair our pulmonary system, respiratory system, cardiovascular system, our kidney, even the kidney or liver, and sometimes during the pollution season, our eyes or our skin might also feel discomfort. So this is one of the examples that our planetary health is directly related with our health. And our planet is actually in severe and urgent crisis at this moment. Earlier, Professor Wang mentioned about the climate changes, the global warming, and now also the air pollution. However, there are also many aspects of the ecological crisis our whole planet is facing, including the ocean acidification, ocean warming, and ocean deoxygenation. It's impacting the life under the sea. And also the biodiversity loss, that is also one of the most severe challenges that we are facing. And it's all due to the activity of human. So how our consciousness can alter this reality, it relies upon us. As a chemist and also studying aerosol chemistry for more than 20 years, we came to realize that aerosol, although it's unseen by our nude eyes, it's closely connected with everything. It doesn't only connected with atmosphere, but also water sphere. For example, some sea spray, when you go to the beach, you can see some of the sea spray aerosols. And it also impacts biosphere. It can impact our health, but also the health of animals and even plants. And also the lithosphere, like the dust. So from this graph, you can see everything is actually connected, and we are a whole entity. And this, I think, Marcus also mentioned about Einstein, and this is one of my favorite quotes from Einstein. He mentioned that a human being is a part of the whole called by us the universe, a part limited in time and space. He experienced himself, his thoughts and feelings be something separated from the rest, which is a kind of optical delusion of his consciousness. And this kind of delusion actually is a kind of prison for all of us, restricting us to our personal desires and affections to a few persons nearest to us. However, our task must be to free ourselves from this prison by widening our circle of compassion to embrace all living creatures and the whole of nature in its beauty. So I hope that by understanding the complexity and the close connectedness of everything, we can see through, we can go beyond the limit of our sensation. And I would like to use several quotes of the famous scientists and the researchers. Like this one is from Da Vinci. He mentioned that we have learned how to see, realize that everything connects to everything else. And as you might found out, all the greatest minds in modern time, especially those in the important figures in the development of quantum mechanics, like Tesla, Schrödinger, Einstein, and Planck, they are also telling us the same thing. Like Tesla mentioned that we are a one, only egos, belief, and fears separated us. And Schrödinger, who is the developer of the wave mechanics, he said the quantum physics thus reveals the basic oneness of the universe. And Einstein just mentioned that he suggested our separation is only the optical illusion. And from Planck, he mentioned that the entire world we apprehend through our senses is no more than a tiny fragment in the vastness of nature. So, by understanding the operation principle, which functions at the very quantum mechanical level, and see its limit, then we will be able to see our close connectedness with our surrounding and with each other. And once we accept our limit, we will have the chance to go beyond them. So this is the message that I want to convey, to deliver, to share with you. And thank you.